Alright guys, I have a quick question asked online about the mean value theorem for integrals. Some of these problems ask you only to find the average value of the function over the interval. This question asks to find the value of c guaranteed by the mean value theorem for integrals, which involves one additional step after finding the average value. So we'll actually do that first, then we'll find the value, or values of c rather, here. So first things first, what is the mean value theorem for integrals? The mean value theorem for integrals says this: if you want the average value over the average value, and by the way, by average value we mean average y value, the average height of the curve over this closed interval, is given by the following expression. It's 1 over b minus a times the definite integral from a to b of f of x dx. So if we want to find the average y value, the average height of the curve, we simply do this. Okay, so the first step is just a matter of plugging in to our expression here. So we want to do, by the way, left-hand side of the interval is always a, right-hand side is b, so that's easy. Here's our function. So we're going to do, let's see, 1 over b pi over 3 minus, notice there's a negative sign built into the function, into the expression rather, minus negative pi over 3, double negative there, times the definite integral from negative a, pi over 3, to b, positive pi over 3, f of x dx, cosine x dx. Okay, we can do a little bit of algebra here. So pi over 3 minus a negative pi over 3 is pi over 3 plus pi over 3. So we end up getting 1 over, there's already a common denominator, that's 2 pi over 3 times, okay, what's the antiderivative of cosine? If you recall, the antiderivative of cosine is sine. So this is going to be times the definite integral. Antiderivative is sine x. We don't have to worry about the plus c because this is a definite integral. And we're going to evaluate at pi over 3 and negative pi over 3. This notation simply means we're about to apply the fundamental theorem of calculus. So let's move over here. Equals. So we can now, let's remedy this complex fraction here. 1 divided by 2 pi over 3 is going to be 3 over 2 pi. Now, we can kind of ignore that for the time being. It's just a constant while we work out the fundamental theorem of calculus here. So this says take sine x, evaluate at pi over 3. Take sine x and evaluate at negative pi over 3. Oh, I don't know why I just did that. Sorry about that. I was talking and saying sine x, so I wrote sine x, pi over 3, and then sine at negative pi over 3, and subtract the answers. Okay? So what do we get? Well, we get 3 divided by 2 pi. Now what's sine of pi over 3? Think about your unit circle. Pi over 3, here I'll draw you a quick unit circle, or at least the first quadrant. So we have pi over 3 radians, and the coordinates of that point are going to be, let's see, 1/2 comma root 3 over 2. So if those are the coordinates, then the sine of that angle is going to be the y value. So we have root 3 over 2 minus, oh, I guess we need to think about negative pi over 3 too. We'll draw the right hemisphere. There's negative pi over 3. Now, what are the coordinates of that point? The coordinates of that point, well, it has the same x value, 1/2. We're still to the right of the origin, but now the y value has to be negative, so negative root 3 over 2. So the sign of negative pi over 3 is negative root 3 over 2. Okay, so now we see, we have a double negative there, so it's an addition. We end up getting 3 over 2 pi times 2 root 3 over 2, which I suppose we can simplify a little bit further as 3 root 3 over 2 pi. Now, don't stop just yet. What we've done, what we've accomplished, is that is the average value of the function. Whatever that is approximately, I don't even know. 3 root 3 over 2 pi, I have no idea. But it is the average y value, the average height of the function cosine x over this closed interval. But, like I said, some questions just ask you for the average value and you're done. The other questions will ask you to find the value of c, that is the x value, or perhaps more than one value, that gives you this y value. That is, take it one step further and find the x value between negative pi over 3 and pi over 3 that gives us this average height. In other words, where does the average height occur? And since cosine is a periodic function, it might occur more than once. We'll just have to see. To solve questions like this, essentially we just need to solve f of x equals, by the way, we call this f of c, the average value. So I'll say we need to solve f of x equals average value. Okay? In other words, we need to solve cosine x equals 3 root 3 over 2 pi. Now, here's the problem. That is not something that you should recognize from your unit circle. Think about it this way. So we're asking what angle is going to give us a cosine value of 3 root 3 over 2 pi. So that's like asking, here x value is the cosine value, so that would be like saying, question mark angle has coordinates, and the coordinates are 3 root 3 over 2 pi, comma something. That's what we're asking. And obviously that's not something you recognize off your unit circle. So what do we do in situations like this? Well, we just use the inverse cosine function. We call it arc cosine, or cosine inverse. So arc cosine of cosine x equals arc cosine of 3 root 3 over 2 pi. And so, of course, the left-hand side just gives x equals. And now as far as what does that value equal, well, let me grab a calculator. Because this is going to be an approximation. We're not going to get a nice value for this. Let's just see, arc cosine of 3 root 3. Be careful typing this into your calculator, especially if you have one of these older ones. You have to be careful with the parentheses and such. Divided by 2 pi, especially when you're dividing by like 2 pi. A lot of times, if you're not careful with the parentheses, the pi will end up on the numerator somehow. So let's see, I think I've typed that incorrectly, and I shouldn't say equals here. I should say approximately equal. Let's see, I'm going to round this to 4 places, I think. 0.5971 if I round to 4 places. Okay, so that is the angle that has, if you're thinking about a unit circle, that's the angle that gives a y value of 3 root 3 over 2 pi. But if you're thinking about just cosine in a normal sense, like a cosine over this interval, that means at the x value of approximately 0.5971, there is a y value of 3 root 3 over 2 pi. That is, we get the average value, the average y value of the function that was guaranteed by the mean value theorem. So there's one solution, but I think because of the periodic nature of cosine, we're going from negative pi over 3 to pi over 3. So we're going essentially along part of the top of a cosine curve. I think we're going to have this maybe twice. And to verify it, think about it this way. If there's one angle, pi over 3, let's see, pi over 3 is approximately 1.047, okay? So pi over 3 is up here. So there's positive pi over 3. Negative pi over 3 is this angle over here. But remember, we said this was that angle 0.59. So that's our x 0.59. So we know that there is another angle right here, negative x, that also has the coordinate, at least the x coordinate, 3 root 3 over 2 pi, comma, I'll say negative question mark, since the y value is going to be negative. So here it's we're gonna have another value of x, or which is gonna be the negative of this x value. It's an angle here that's going to give us the exact same cosine value, because cosine is positive in the first and fourth quadrants. So the other solution is going to be x is also approximately equal to negative of this value, 5971. Okay? Because we know that that is an angle that's less than pi over 3 radians, so this is an angle that's going to be less than negative pi over 3 radians, a smaller negative number, so it's also going to be in this domain. So 2 solutions guaranteed by the mean value theorem for integrals. Again, if you just apply the mean value theorem for integrals, the solution you get will be the average value, the average height of the curve. If you want to find where that average value occurs, you need to set the original function equal to the average value. And a lot of times it's easier to solve than this, but since this was a trig function, and since this is a weird average value, then you have to end up using arc cosine. And then just think about unit circle, think about how the periodic nature of cosine, and you get your other solution. Okay? Have any questions? Feel free to post on Blackboard. I'll be more than happy to answer your questions there. Otherwise, see you soon. Have a nice day.